This is KP Sajith from the Department of Silver Hills Public School. So, wave optics. Optics, you know that optics, it is the study of light and the related phenomena, and the study may be about the optical instruments also. This branch, it is that much developed, it is special branch. For example, we know that nowadays the telescopic contact lenses are also there, and such optical instrument itself that much developed, and by wearing that even our zooming capacity of eyes, it is that much enhanced 3 or 4 times than that of the naked eye. Or not only that, the branch optics, we know that we are observing or we are analyzing, we are understanding the nature of the universe around us, nature of the world around us through the light. Now, what is the nature of that light through which we are analyzing the nature of the universe around us? So, in that sense, it is very interesting, and there are many point of views. Light, it is a particle, it travels in a straight line, and some other point of view, and it is not a particle, it is a wave. So, of course, we know that if you are saying that light is a particle, some speciality of particle, just like mass and momentum, it should be coined with that. And also, if you are saying that it is a wave, the property features of a wave, you know that frequency and wavelength. So, if you are considering that light travels as a series of little packets, then each small packets of light, but we know then it is directly opposite to the wave theory. It is opposite to the wave theory. If you are believing that light consists of stream of particles and it travels as a stream of particles, yet despite of that particle nature, for example, quantum physics, it gives a particle picture of light, and each particle, it is known as photon, and to describe the energy of that particle, which we call photon, energy of that particle, we know that is h nu, h is the Planck's constant, but that term nu, that is a frequency, and frequency, it is the speciality, the characteristics of a wave. So, the particle nature itself, it is complemented by the wave behavior. So, this particle nature and wave nature, they are complementing each other. So, I would like to say that they are not contradicting each other, it is a complementation. So, both this nature, it is, the light, it is unique. So, the particle nature or the wave nature, I can say that it is an organic nature in the unique existential behavior of the phenomena called light. So, light and the related studies, it is that much important. And some phenomena, suppose if you are saying that light travels as a straight line, light travels as it is sent and it comes back as it is getting reflected through in a straight line, and in that sense we have to rule out the chance of bending. So, whether light can bend, whether the light is that much flexible. Of course, in modern physics there are many instances. For example, in general theory of relativity, during that time Einstein predicted that in the early 20th century, Einstein predicted that light can bend due to the effect of gravity, gravitational field can bend that light. So, I think that history, it is, you may be aware of that. So, Einstein predicted in early 20th century, predicted that light can bend around a star due to its immense gravitational pull, and the other scientific world, Sir Arthur Eddington and such legends of physics were curiously waiting to test whether this statement, it was true or not. But in 1919, during that total solar eclipse, scientists moved different parts of the world, and they have located the apparent position of a star just before the total solar eclipse and after that also. So, they were able to point out there is a change in the apparent position of that star. So, it was proved. What Einstein predicted mathematically, that was proved by experiments. So, that time, the first time, the Newtonian ideas were overthrown. So, Einstein becomes a world famous scientist. So, this is a story, and it is the real incident, and in which we can prove that light can bend. but that bend that is not due to the effect of gravity. Gravitational force is bending the path of light. And is there any other effect in which we can observe the bending of light? For example, suppose we are taking a source of light, there is source of light, and light propagates from that source, and there is a blocking, we have blocked it, and then a small opening is made, just a pin, sorry, just a small opening, very small opening. Now we are placing a screen also placed, screen is also placed. Now we know we are finding a bright spot here, and then when we are comparing the bright spot with that of the opening, actually if you are believing in the straight line rectilinear propagation of light, the size of the opening that should be equal to the area, the width of that, both should be same. But we are able to find that whenever we are moving the screen away or adjusting that, or it is possible that when the slit width is comparable to that of the wavelength, the opening of that opening, when it is comparable to that of the wavelength, it is possible, it is finding that we are getting a bright spot and its dimension, it is wider than that of the opening. So how this is possible? If we are relying upon the rectilinear propagation of light, this is not at all possible. So this is possible. For example, you know that here it is blocked, so this should be the shadow region, and here also shadow region will be there. So we are getting a wider bright spot, it means that light is encroaching to that geometrical shadow region. Encroaching in the sense light should bend and fall there, light is bending. So the question to make that bending, so here it is not to the effect of gravity or not due to other field, light is an electromagnetic wave, you know that, and see we are going to have that idea, because if we are not introducing the term wave, the wave nature, this phenomena is not explained. So the straight line path, if it is traveling as a straight line, we know the opening should be of the same dimension, that of the bright spot should be of the same dimension as that of the opening. So how to explain this? It is bending. So is it that much flexible? Flexibility is the light is having a body to, you know that if it is having a body, it should have a mass m, and if there is a mass m, it will be affected by gravity. Already Einstein has proved that. So anyhow, this bending of light, whether it is due to gravity or whether it is, you know, due to this phenomena that light is passing through a narrow opening, very narrow opening, or a straight edge, that bending is happening. So, or suppose we are using two lights. For example, you know, I remember a famous quotation by Max Born, the famous physicist. He is saying that light plus light does not always give better light. Sometimes that will be darkness also. So if we are using two light sources, we are expecting that better brightness will be there. But it is possible, we can prove that if you are using two single light sources having certain speciality, we will be discussing it in detail, and at some points of the screen we are getting some dark regions also. So how is it possible? Here also, if you are adjusting the slit and if you are adjusting the distance between the slit and screen, we will be able to find many interesting pattern, and this bright spot then it will be encircled by a dark region, then once again it will be, then the new bright circles are coming, like that this concentric alternate dark and bright fringes are formed. So how to explain that? And in the case of double light sources, double slit, suppose you are making one more slit here, one more opening, then also we are getting concentric circles, alternate concentric circles, that bright and dark circles. So if we have two slits, then it is the interference, and if it is having only one slit, it is the diffraction. General definition you may be knowing, diffraction happens when light is bending, light deviates from its path as it is traveling, as it is coming out through a narrow opening or a straight edge. And interference means light from one slit that superposes with the light waves, light coming from another source. So, we have to introduce the propagation of light, that propagation of light, the concept, the propagation of light as a wave. So, we know that any knowledge comes in physics or in the world of science and technology, it is due to the advancement or it is due to the development of human consciousness itself, or we know that the experimental or the scientific ideas, it will be helping our consciousness to expand. So, if you are searching in many areas in which human beings are involved, it may be literature, arts and science or pure mathematics, some concepts are evolving from that. For example, a Russian fictional writer, that is saying that if you are going nearby a pond and throwing some pebbles to that pond, and if we are not able to observe the spreading of that circles, if you are not finding that graceful circles expanding, then your occupation is useless, like that. And then comes a scientist, Christian Huygens. So, what he has done, that he has proposed a new theory, and in that he has compared the propagation of light with that of a mechanical wave. Light is not mechanical wave, we know that it is electromagnetic wave, it needs no medium for its propagation, but this theory we can compare the propagation of light as that of the propagation of a wave produced in a given medium. So, there are some basic concepts in that. So, we are going to analyze the Huygens theory, and Huygens theory or the hypothesis. We know that in every theory some underlying concepts will be there, basic principles, simple one. So, as usual we are going to analyze that basic principles, and if you are able to get a clear idea about that basic principles and terms, then just we have to correlate them, then we will be having the perfect knowledge about that theory. So, we are going to learn about Huygens principle or Huygens theory, and in that some terms are there, just like wavefront, wavelets and coherent sources. Frequency, you know that, what is the general meaning of frequency. So, mainly it is about wavefronts and wavelets. General meaning, you know that what is a wavefront. So, if you are dropping some stone on the surface of water, and here surface of the water means it can be any medium, according to Huygens theory it can be any medium, but that medium is having some specialities. The medium should be homogeneous and isotropic. Homogeneous and isotropic means it should be characterized by the same property everywhere, the material density and maybe the optical density, and everywhere it should be having same property, the medium is uniform and homogeneous. So, just to drop a stone on that surface means the surface it is still, and we are going to disturb the calmness of that surface by dropping a pebble, or you can puncture the calmness of that surface with a pin also. So, with a pin prick we can disturb that. So, we will be able to find that as that Russian physicist told, Kosma Predkov, we will be able to find that graceful circles spreading over the surface of that medium. Okay, so, the concepts like wavefront and wavelets. Wavefront, we know that. So, if a object is dropped on the surface of water, you know, the stone will be having its incoming stone will be having its potential energy and kinetic energy, and all this energy will be transferred to the molecules of that water, and the calmness is disturbed. Then this disturbance will be transferred to the neighboring molecules in succession. So, in that sense, you know, it is a kind of, disturbance is progressing in all direction. Concept of wavefront. So, the wavelet in the sense you can see that it is derived from that the wavefront. Suppose I am dropping a stone, and suppose around us some wavefronts are originating, then each point on the wavefront, for example, see this disturbance is traveling in this direction with a certain velocity. the motion and everything, the energy, propagation, everything. So, at one instant some molecules are coming up and I am locating the positions of all molecules, then that wavefront is constructed. I am saying the general meaning. Then all those molecules, it will be having that energy, it will be disturbing its neighboring molecules. So, what is the velocity of this wavefront? With the same velocity, the new motion, new disturbance also will be spreading. So, that is the meaning of, general meaning of wavefront and wavelets. So, these terms are used in Huygens principle. First of all, the medium isotropic and homogeneous, then a disturbance is produced, and if the medium is isotropic and homogeneous, then we know that in a certain direction when the wave is travelling, suppose it is getting damped, the amplitude is decreasing. For example, suppose this is the point source of disturbance and the waves travels like this and the amplitude is decreasing, and if the medium is having same property everywhere, then the damping will be same in all directions, because everywhere the medium remains the same, and amplitude it is decreasing. And so, if I am locating some points which are equidistant, so equidistant from the source, up and down motion of the molecules, it is transferred, amplitude gradually decreases. So, for example, 1 meter away, suppose I am locating what is a particle and its amplitude, and suppose I am locating a particle which is 1 meter away in this direction, and 1 meter away in this direction, and 1 meter away in all directions. So, since the medium is characterized by same property everywhere, in all directions the velocity will be the same, and the amplitude of molecules which are vibrating also will be the same. So, if this molecule, if its amplitude is 0.5 meter, and this also will be having same amplitude everywhere, means the points which are equidistant from the point source of disturbance, they are vibrating in the same manner. Same manner means in their amplitude, in their frequency. So, if I am locating all those points which are vibrating in the same phase, as already I told that wavefront, the concept of wavefront. So, in this way we can explain that concept of wavefront more clearly and more technically. So, if I am joining all those points, in mathematics we have a term locus. So, the locus of all those points which are equidistant from the point source of disturbance will be circles. That is what we are getting circular wavefront. We know whenever we are throwing a pebble on the surface of water, circular wavefronts circles are created. Now, with these concepts, and as I told you that this point it vibrates, it is having its own amplitude. Now, what happens? It can set its neighboring molecules in motion, a wavefront. So, each molecule it can act as, in that sense it can act as fresh source of disturbances. Now, again disturbance will be spreading from that points. In this case, we can say that wavelets. So, this circle, it is the wavefront. Now, from that each point is a new source of disturbance. From such sources of disturbance, wavelets will be starting. That is a wave itself. So, here again what I can say, I can draw circles, again circles can be drawn, again circles can be drawn, and again if I am drawing a common envelope, now you can see that I am getting a new shape like that. So, once again the Huygens principle, let us analyze in a systematic manner. For example, there is a point source, this is a point source S, then suppose I am naming it as S1, S2, and how we got this S1, S2. So, I just located some points which are in the same state of their vibration, means they have same amplitude, same frequency like that. So, suppose there may be some points A, B, C like that. Again these points they will be acting as fresh sources of disturbances. And suppose the original disturbance, it is travelling with a velocity v, the v is the wave velocity. So, then from this source also, from these points also, the disturbance will be travelling with the same velocity. So, you can say that wavelets from A, B and C, they also will be travelling with the same velocity as that of a wave. And so, this is the point source. So, again we are determining some points equidistant from this. So, again the locus will be circles. So, here also circles and here also. Now, let me draw a common tangent to these new circles drawn. If I am drawing a common tangent, or all those circles are enveloped. So, the new envelope, that the new common tangent, let me name it as the first one we have named it as S1 and S2, and the new, let me name it as S1 dash and S2 dash. So, in that sense I can say this is the, suppose S1 S2, S1 S2 according to Huygens principle, it is named as the primary wavefront. Now, each point on the primary wavefront, it is a fresh source of disturbance. So, the wavelets are emanating, spreading, propagating from that point. Again we have done the same thing and we have drawn the locus, and again that is circles, and a common tangent drawn to all those circles will be giving the shape of the new wavefront, that is a secondary wavefront. So, S1 dash, S2 dash, this is the secondary wavefront. Like that we can explain the spreading. So, this is the basis of Huygens theory, the concepts of wavefronts. And of course, you can consider any points, and the thing is that the wavelets they travel with the same velocity of the wave. Suppose v is the velocity of the wave, and now from this point, suppose delta t is the time taken by the disturbance to travel in a direction. So, v delta t will be the radius of such circles. So, in this way the Huygens theory is explained, and you know that it is in a theory sometimes mathematical derivations will be coming. So, but here it is just a geometrical construction. So, we can say that Huygens theory essentially it is a geometrical construction, and it enables us to locate, or it enables us to predict the shape of a wavefront if the shape of a wavefront at an earlier time is known to us. Because here you are able to locate or predict the shape of the secondary wavefront S1 dash, S2 dash, because we know the shape of the wavefront S1 and S2, the primary wavefront. We know that because, or we are able to locate that. So, that is the one important postulate of Huygens principle. It enables us to locate the position of the wavefront if we know the position of a wavefront at an earlier time. And now whenever we are going to analyze any phenomena exhibited by light, we will be discussing it in terms of the wavefront. And earlier we know we have done everything according to the rays, incident ray, reflected ray or refracted ray or polarized ray, plane polarized ray, many things. So, here that ray it is nothing but a straight line propagation of light. So, the ray ideas it will be replaced by, or we are going to analyze every phenomena on the basis of wavefronts. Of course, if you are interested, the rays, you can consider, if this is the source of disturbance, now you can consider it as a source of light itself. So, this is the analogy given by Huygens, Christian Huygens. Now, we can compare the propagation of light to this. and this is suppose it is it is a mechanical wave on the surface of any medium, but light is an electromagnetic wave, it is entirely different, but we can compare. So, the propagation of light in a medium as told by Christian Huygens, that can be used, that concept can be used to analyze the propagation of light, and of course, by using that we should be able to explain all other phenomena exhibited by light, then only that theory will be a successful one. So, if you are applying Huygens theory, we are able to prove and we are able to explain all other phenomena satisfactorily. So, in that sense, this Huygens theory is a successful theory. Now, based upon these concepts of wavefront, you will be expecting some questions, maybe 2-3 marks short answer questions used to appear in your paper. And for example, how to differentiate between rays and wavefront. Ray, that is a straight line propagation. So, it just shows the direction in which the energy flows. So, if it is a disturbance, that the energy is traveling from molecule to molecule, and if it is a light, we can consider light as a source of electromagnetic disturbance in space, if there is a source of light. Now, everything you consider that it is a source of light itself. So, if there is a bulb, we know that light rays will be propagating. So, light rays. Light rays. So, ray, it is nothing but it shows the direction of propagation of energy, and whenever we are comparing the rays and wavefront, the wavefronts and rays, they are perpendicular to each other, and also see if there is a source, we can construct the successive wavefronts, primary, secondary, like that, and if I am drawing the rays in all directions. Now, see, the medium is, it is characterized by same property everywhere. So, the time taken by that energy, means the propagation of light from one wavefront to another wavefront along all direction, it should be the same. Means if you are considering this ray, means the light takes same time to reach from one wavefront to another adjacent wavefront in all directions. Time taken by light in this direction to travel from this wavefront to its adjacent wavefront, and this also it will be the same. These are the main postulates of Huygens principle. Now, coming back to the fundamentals of optics, that in ray optics, the image formation, you have to plot the image formed by spherical mirrors and spherical lenses also. So, how we can use this wavefront instead of rays to construct the ray diagrams, or sometimes you have to plot the reflected wavefront, or you have to plot the refracted wavefront, and the image formation, or the location of the object from that mirror, like that. So, actually here two types of wavefronts are there. One, as we have seen, that is a circular wavefront itself, but when the waves are propagating at a large distance, when waves are propagating at a large distance from that point source, whenever we are observing, we will be finding a portion of that only. So, that will be appearing as plane wavefront. So, plane wavefront, that in ray optics, this parallel beams of light, it is associated with infinite distance. Infinite distance means somewhat considerably greater, larger distance. So, if the source of light is, or the source of disturbance is somewhat away from us, then we will be receiving the plane wavefronts, and if the source of light is very near to us, the point source of light, then we will be considering the circular wavefront. These are the associated concepts. Suppose a convex lens is given, and if the object is at infinite distance, then we have the parallel rays of light. Okay, so if you have some confusions when you are when you are attending any question, if you have any confusions in considering the wavefront, no problem, you can do everything according to the ray ideas. Draw the incident and refracted ray, then you can construct the corresponding wavefront, because you know the relation between wavefronts and rays. Wavefronts should be perpendicular to the rays, like that. You remember that diagram now, concentric circles and equidistant circles and rays, the arrow marks are going outside. You have studied a similar diagram now in the equipotential surface, that is equipotential surface, the concentric circles and like that. Anyhow, so here the question is that plot the refracted rays, refracted wavefront. You have to plot the refracted wavefront when some plane wavefronts are incidenting on a convex lens. So, let me take a lens and of course, the principal axis, and the plane wavefronts are incident. Plane wavefronts means, you know, the source will be at some greater distance, larger distance. Suppose these are the plane wavefront. Let me name it as A, B, C, D, like that. You have to mark everything, optic center and everything, okay. Just I am showing how to plot the shape of refracted wavefront. So, you know, if there is some wavefront, you can plot the corresponding rays, and rays should be perpendicular to the wavefront. So, in such a way, you know, a straight line it should be straight line. So, I should take that straight line. So, this is a ray and this is another ray, and you know, if you are considering the this rectilinear propagation, this concept is clear to you. Otherwise, see the wavefront, suppose you are relying upon the Huygens principle and wavefront itself. So, first of all, you have to consider that only, not the rays. So, to clear the confusions, just I have drawn that. If any confusions, if you have some confusions between, then you can draw with the rely upon the ray diagram, and then you construct the corresponding wavefront, then the idea will be clear. So, here, you know, when it is focused, there will be a bright spot, principal focus, that bright spot, and that bright spot you can consider another source of light. If it is done in dark room, that bright spot will be, you know, a point around that light spreads. So, if it is a point, what will be the shape of that wavefronts when it is appearing on the other side? The point is very near to that, that will be spherical wavefronts itself. Or you consider that this plane wavefront, when it is passing through the lens, and the middle part of that lens it is thicker and upper and lower part it is thin. So, the wavefront, that light, it will be undergoing greater optical density when it is passing through the middle part. So, the middle part of the wavefront which is passing through the lens, it will be, its velocity will be decreased. So, that part will be lagging behind, whereas the upper and lower part it is suffering very less density, very less, you know, that thickness is very less. So, that part its velocity will not be that much affected. So, it will be leading. So, in such a way, how to draw that? So, suppose first of all AB. So, this I can write that this AB, when it is coming the other side, let it be A dash B dash. A dash B dash, it is the refracted wavefront corresponding to the incident plane wavefront AB. First it is appearing there. Then comes CD. So, that also changing its shape, C dash D dash. So, you can see that this is a bright spot, and around that, you know, light can spread. So, we are getting circular ripples like that. So, when the plane wavefront is passing through a convex lens, it changes its shape. So, like that many questions can be asked. For example, if it is the circular wavefronts, suppose we have convex lens and circular wavefronts are approaching, suppose A, B and C, D. circular wavefronts means you know that point source of light, that light source will be very near to that. So, we know when the object or a source of light is placed near to that, suppose at f or between f and the optic center, then the light after refraction, you know, it will be sent as parallel rays like that. So, see what I am saying, if we wanted to correlate your this ray, light ray and wavefront, you can do that. So, if this is the point source, then you know very near to that, very near, then the rays will be parallel, send parallel, and rays and wavefront, they are perpendicular. So, on either side also these are the refracted rays, then first AB is passing through that. So, this will be that A dash, B dash, and then C dash, D dash, like that. So, for 1 mark it can be asked, and you know that as usual the middle part it is thicker, and here AB, its middle part it is leading, middle part of that wavefront it is leading, and the upper and lower part it is lagging. But when it is passing through the greater thickness, the middle part which is lagging, which is leading, that becomes little bit lagging, and this part which was already just behind, it will come in front. So, a straightening effect that will happen. So, in that way you can predict. And if it is convex mirror or concave mirror, it is possible. For example, we have concave mirror, and if parallel beams of lights are coming, then we know those light rays will be focused to a single point, that is the principal focus. Okay. So, suppose AB and CD. So, on reflection, how the shape is changing you can predict, because this part it is little bit you know inward. So, the upper and lower part it will strike the mirror first of all. So, the upper and lower part it will be starting their reflection first of all, then the middle part of the wavefront it will take some time to reach the polished surface. So, on reflection that will be lagging. So, it will change the shape of the reflected wavefront in this case, or you can check, suppose I am considering the rays. So, rays are parallel, and on reflection you know it will be focused to a single point. Now, just to predict the shape of the refracted wavefront, what will be the shape? You can check that the upper end it will be leading on reflection. So, I can say AB is first reflected. So, that will be A dash, B dash. So, you can see that this part it is leading, and the CD it went inside and it took some time to reflect. So, the middle part of that wavefront it is just lagging, then CD is coming, then that also will be reflected, C dash, D dash, like that. So, any case, suppose it is prism, or if it is suppose concave lens, it is possible. Concave lens, middle part is thin and the principal axis. Suppose we are sending parallel beams of light, or the wavefront, suppose the plane wavefront AB and CD, then what will be the shape of the wavefront at the other side? As usual, you know that the middle part of the wavefront that is passing through the thinner region of the lens, and its velocity will be affected somewhat in a small amount, and the upper and lower part, it has to pass through the greater thickness of the lens. So, the velocity will be that much affected and the upper and lower part will be lagging behind. Or see, considering the rays, and we know that this is a diverging lens, it will be diverging the rays, and we will find that, we will feel that these rays are this virtual focus. So, how to plot that, this upper and lower part it is lagging and the middle part it is leading. So, you can construct the wavefront in such a way, you can check it. So, if I am drawing in this way the refracted wavefront can be plotted according to the shape like that. So, you can check that which is correct. If I am drawing like this, here the middle part it is passing through the lesser thickness. So, that middle part it is leading, and this will be the first wavefront. Here it is CD. So, first of all which is coming out, that will be C dash D dash, and this will be A dash B dash. So, like that we can plot. And if it is a prism, suppose we have a prism, a parallel beams, what happens, it will be deviated towards the base of the prism, towards the base. So, if you are considering the wavefront ideas, the plane wavefronts, then as usual at the apex the greater thickness and the lower part of the wavefront that has to pass through the greater thickness, much refractive index. So, the velocity of the wavefront will be affected near the apex in that much manner, and near the base it is having greater thickness. So, apex it is having less thickness. So, the part of the wavefront, the lower part of the wavefront which is passing through the base of the prism, its velocity will be that much affected. That part when coming on the other side it will be lagging, and the part of the wavefront which is passing through the apex and it is very thin. So, velocity will not be that much affected. So, that will be lagging. So, in that sense an effect will be created like this. If this is AB and the first refracted wave, that will be A dash B dash, and this is CD is coming, then C dash D dash. So, if you are drawing the rays, it will be like this. So, rays are perpendicular to the wavefront, and here also the rays you are drawing, it is perpendicular to the wavefront. So, in this way we will be able to predict the shape of refracted wavefront or sometimes reflected wavefront using Huygens principle. Now, this is a postulates, Huygens postulates, Huygens theory. So, we know that every theory, every postulate, it has to be proved either by doing experiments, an experimental proof. That the prediction by Einstein, it was proved by experimental verifications, and it should be supported by the mathematical analysis. So, this Huygens principle, it is very useful in analyzing the interference phenomena, because the phenomena of interference, if you are applying the ideas of ray optics, it is not at all helpful in analyzing that. But if you are going to apply the concepts of interference and represent that wave as a sine wave or cosine wave, because we know that sine wave and sine function and cosine function, that can be used to represent the waves. So, that we can prove, we will be proving that. So, we are using Huygens principle to explain the phenomena of interference. So, first of all we should know what is that phenomena exactly, interference. As the name indicates, that is a kind of interference. So, there is one source and its wave is interfering with the other source. So, a general idea, the one source, and so the concept of interference. So, one wave should interfere with the superimpose with the other wave. So, here just a general view, you can see that it is propagating from main source, and then two slits are there, and from the two slits again the waves are emanating, and we will be getting the superposition. So, if we are using the light sources, we know usually if it is any mechanical wave, there are some conditions, that the crest of one wave will be coming over the crest of other wave, then there will be a big crest. So, a kind of the disturbance it is constructed over one over the other, that is known as constructive interference. Now, when the crest is coming with the trough, so the disturbance, it will be cancelled by the other. One is having upward disturbance and other will be a downward disturbance. So, that is known as destructive disturbance. So, this is in general. Now, here you have seen that there is, first of all, there is one source, and suppose it is a light source, suppose it is a light, and suppose we are using another source of light, but here we are not doing that. One source it is there and then it is blocked. Then on that blocking, suppose we are making two pinholes, and each pinhole that can act as a new source of light. So, light from these two pinholes will be incidenting on the screen, and there we will be getting a special pattern, a concentric, alternate, bright and dark patterns we will be getting. So, the 1, 2, 3 questions. First of all, why we are not taking two independent source of light? Suppose we needed to, we needed two sources. Suppose I am taking a particular bulb and it is made up of some company, and maybe Philips for example. Suppose I am taking another bulb of same voltage rating and is made up of same company itself. But I cannot assure that condition of sustained interference, because we know at a point when the crest from one wave is reaching, at the same time the other source should send a crest to the same point. So, crest from two different sources should reach that particular point at the same time. It means that the vibrations should be almost alike in the same sense, maybe having the same frequency. If one wave is having some frequency and if the other wave, if it is exactly out of that, then this interference cannot be, that is a sustained interference cannot be observed. Why is it so? Because we know light it originates from the atomic excitations. So, in a source we cannot assure how many number of atoms are exciting at one instant and getting de-excited. Essentially, light, it is a short pulse from an atom, and that can, that will be sustaining, that will be existing for a short duration only, almost 10 power minus 9 seconds, like that an atom is emitting its energy in the form of visible radiations. So, to avoid this condition, this problem, we are using one single source and it is blocked by a screen, and then on the screen two pinholes can be made. Now, two pinholes they are separated, but the light or the waves from those pinholes, it is derived from same parent sources. So, whatever differences will be there for the light coming, whatever specialities will be there for the light coming from the first source, same speciality will be for the light coming from the second source, because both are derived from the same parent source. So, in that sense we can say that those two lights or those two slits, they will be acting as two different waves. They are in phase, means same frequency. Okay, amplitudes can be differ, no problem, but they should be of same frequency. same, then we can say that they are in the same phase. So, this type of sources are known as coherent sources. So, in this way we can attain coherency, named coherency. So, if two sources are to be coherent, those sources should have exactly the same frequency. So, in this way we can produce two coherent sources. Now, coming back, this is an example I am showing that it is a propagation of wave on the surface of water maybe. Now, if it is a light wave, so every term connected to light only, light, the frequency of light and the phase difference between the lights. So, here two terms are coming, phase difference and path difference. You know, these terms are associated with the wave. What is the phase of a wave and what is the path length travelled by a wave. Suppose two waves are there, and if they are travelling to different length, then length of the path travelled by, the difference in the length of the path travelled by these two waves can be treated as the path difference. So, when the path difference, it is having some certain discrete values, some specified values, it is observed that we will be getting constructive interference on the screen, and when it is having some other values, some discrete special values, we will be getting destructive interference on the screen. So, this has to be proved mathematically. First it is the mathematical proof, then that can be proved experimentally also. So, to prove it mathematically, so we have to take either we can approach it by taking sine functions, displacement y is equal to a sin omega t or y is equal to a cos omega t, like that. So, let us analyze that. So, this is the experimental arrangement in which we are going to devise an arrangement needed for analyzing the interference pattern that we have seen that. Now, in next session we will be analyzing the mathematical approach, how to analyze the interference. Okay, thank you.